fairly quickly. So we're actually only doing 7 and 8 today. We'll be doing 9 and 10 on Monday. I think we have a normal Monday schedule, so we should be able. We'll do those on Monday. So the combination formula is very similar to the permutation formula. So if you remember the permutation formula from Tuesday, it was NPR equals n factorial over n minus r factorial. Our NCR formula is actually very similar, uses the exact same variables, and they are the variables have the exact same meaning. We have n factorial over n minus r factorial. Then we add on we're multiplying the denominator by r factorial. What this little piece does here is it removes order from it. And what I mean by removes order, if I were to, the first example here, it mentions that a teacher has 22 students who leave trash in the classroom. The teacher chooses 3 students at random to stay after class to help clean up. How many different combinations of students are there that can stay behind? Say I was to choose 3 students for this class to stay after to clean up stuff. So say I was going to pick Dragan, Costanza, and Justin to pick up trash afterwards. And then the next day I was going to do the same thing, and instead I picked out Justin, Costanza, and Dragan to pick up trash. Is there any difference between those? There isn't, because they're doing the exact same job. So what that r factorial does is it removes that it removes the flipped order from it, because the order doesn't matter for combinations, so we don't need it. So that all that extra r factorial is it removes the alternate orders that are possible. Our values for these are exactly the same, where n is the total number of items. N is total number of items. R is number of items chosen. So n is total number of items. Sorry, that's off the screen. Total number of items. R is the number of items chosen. This is really bright. There we go. It's maybe a little better. Okay. So for this first one, I'm actually gonna expand it out. For the second 8, we'll actually show you in the calculator, the short way to do it in the calculator. So I'm gonna show you both. So on number 7, going back to the picking up trash problem, we're told that we're choosing from 22 students and that we're picking 3 students from those 22 students. So our n is our total number of items. So what's our number for our total number of items for this? How many are we choosing from? Well, we're choosing 3, but how many are we choosing from? 22. And then we're taking 3 students out of this pool, so our R is going to be 3. So if we're writing this out, it's NCR, where in this case it's going to be 22C3. Plugging those into the formula, it's going to be 22 factorial over, in parentheses, 22 minus 3 factorial, and then it's going to be times 3 factorial, that's in the denominator. So I'm just switching out the variables. What this is going to end up equaling is 22 factorial, if we do the subtraction piece. 22 factorial over 19 factorial, then 3 factorial. So if we're expanding this by hand, so we talked about this on Tuesday, and then I taught you a calculator way to do it. Same thing here. I'm going to teach you the expanding way by hand, and then I'll teach you the calculator way on 8. We want to cancel out as much as we can in that denominator. So in this case, our biggest value in the denominator is 19. Sometimes you'll run into situations where the bigger factorial is not the first factorial. Sometimes it's the second. You always want to try to cancel out the bigger factorial. So in this case, we're wanting to cancel out the bigger factorial. So I'm going to rewrite 19 factorial down here. And I'm also going to write 19 factorial up here, because I'm going to pull 19 factorial out of the 22. The 3 factorial is still hanging out down here. So since I'm pulling 19 factorial out of 22, it means I need to make sure that I list all of the numbers that are not in 19 factorial, which is 22 times 21 times 20. So when I pull that 19 factorial out of the 22 factorial, what's left behind is that 22 times 21 times 20. Because really what this is saying is that we can keep going on 19 times 18 times 17 times 16 times 15 times 14, all the way down to being multiplied by 1. And the reason I want to choose the biggest one is because that means I can cancel out a lot more. So the 19s, I can cancel those out because when you divide something by itself, it's just going to be 1. So it effectively removes it. If we multiply something by 1, it's just going to be itself as well. So what this leaves behind is that 22 times 21 times 20. And that's divided by our 3 factorial, which, if we expand that out, is 3 times 2 times 1.
That's all you do.
And then at that point, you do the multiplication, and you're using a calculator. So it'll be 22 times 21 times 20. And then we're going to divide that by 3 times 2 times 1. So, did you not use parentheses on a division piece?
No, I didn't.
That's where you want to be careful on that.
So it's divided by parentheses.
So make sure when you divide here that you use parentheses, or you do the multiplication first. You could also just divide by 6, because 3 times 2 times 1 is just going to give you 6. If you don't use the parentheses, what it's going to do is it's going to take 9,240, divide it by 3, and then multiply it by 2. So you don't want it to do, you want to make sure that it's dividing by 6 rather than just dividing by 3. So then so that ends up with 1,540 different combinations of students that the teacher could choose to pick up trash in the classroom after class. Yeah, it's a lot of different ways. Any questions about how we got 1540?